right. Hi there, everyone. It's so good to have you all here tonight for the session 1 of Energy 101. My name is Kate Salamito, and I'm the Experiential Learning Coordinator at the Irving Institute. And I am the host of the Energy 101 series this fall. So right now we're in session 1, and the topic of our discussion today is going to be energy systems in the US and around the globe. And I'm really pleased to hand off the microphone to Elizabeth Wilson, who will now introduce herself and get us going.
Hi, everybody. This is Elizabeth. Our goals with this Energy 101 session, which Kate really helped to put together a great series of speakers here, are trying to help us all see from many different perspectives how energy use and production impacts society and vice versa, and how the different pieces of the energy system connect with one another and affect one another. And then thinking more critically about ideas of energy transitions. You'll note that's in plural, transitions, and you'll see why very soon, but we're thinking regionally and contextually about our energy systems and the energy systems around the world. So first, because it is late at night, we were joking earlier today that this is pajama time, we're gonna be having a cup of tea. And I would like you in your first breakout group, we're putting you in a group with 3 other people for 7 minutes, to introduce yourself, talk a little bit about why you're here, and also explore all the different ways you can heat up water for this cup of tea. What different ideas you have for heating water. And so with that, we'll be sending you into the first breakout room now. So in the Dharma students, you guys should all know how to do this now. On the annotate button, you can write on the slide, click the draw button, and you can write on the slide your ideas of how you're going to boil that cup of water. So someone's heating their water with geothermal. There's an electric kettle there. Someone's putting it in their handbag. Natural gas, geothermal, solar, nuclear. Leave it on a car. There's some liquid natural gas. There's some solar heat there, solar PV, sun, microwave, always a good one. Oh, that's a microwave oven that someone drew. Oh, there's a kettle there too. I mean, the point that I think we're trying to make here is there's lots of ways of getting hot water, and there's many different ways of doing it. And so, you know, as people say, there's many ways to skin a cat. But Amory Levins from Rocky Mountain Institute says, you know, people don't want energy. People want cold beer and hot showers. And I had a British friend who quipped, or cold showers and warm beer if you're British. I don't know if that's true, but I thought it was a funny little comment back. And so when we're thinking about energy, energy use, energy services, I just wanted to push us all to think not only of the technologies we use for generation, but also really what we're after. If we're after light, if we're after thermal comfort, if we're after a cup of tea, because I think that really helps to decompose how we use energy in really creative ways. And that ends up being really important for thinking about these energy transitions and energy needs we have in very, very different contexts. And so with that, I'm going to clear all of these drawings. Thank you very much for these. And I wanted to share with you the book that I'm basing this lecture on is a book by my colleague Hope Jahren. She's a professor in Norway now. She wrote Lab Girl, for those of you who've written this. And this lecture right now is based on chapter 10. And chapter 10 on energy really looks at this whole book from 1970 to now, the last 50 years for the whole book. And she looks at food, she looks at water, she looks at plastics, she looks at clothing. But really in chapter 10, she focuses on energy. And this idea that from 1970 to now, we have 3 times greater energy use, 4 times more electricity use, and about 40% more people on the planet. And so energy has really grown per capita. And while the US is only 4% of the global population, we're about 15% of the energy use and 20% of global electricity. And so this story of more is really the story of how we use more energy. And she does a really nice job in the book of illustrating that by talking about the sewing machines in her living room growing up. They had her grandmother's sewing machine, which was a treadle sewing machine. You put your feet on that thing in the bottom there, and you would use that to push and pull the thread through the cloth to make your clothes or your drapes or whatever. And then in her lifetime, her mother got an electric sewing machine, one of the first Singer electric sewing machines, and would be making the clothes and everything for the family. And then today, if you think about how energy is used to make all of our clothes, these are industrial sewing machines that are usually part of a fabric and clothing international pipeline with cloth produced places, assembled in other places, and shipped around the world. And so when you think about the energy embedded in both the making of the operation of the sewing machine, but also the supply chain story, I just want you to appreciate that this has really evolved over time in some significant and important ways. And with that kind of change comes different ways to think about energy over time, over space, over our professional lives, over our school lives, over how we use energy with our friends and family. We've had a huge shift from human labor, like raking leaves, go to leaf blowers or mechanized labor, and even things that we used to just pick up and read like a book can now also be plugged in. So in your second breakout group, I would like you to think about the last 50 years and how energy use has changed. And we'll send some little notes to your different groups, but I'd like you in your groups to just introduce yourselves again. We want to get you to meet as many people as possible during these times, but really pick a few areas, and we'll look at recreation, we'll look at friends and family, we'll look at school, we'll look at work, and just over a 50-year period, how energy use has changed.
I have a colleague at University of Lancaster in the UK, Elizabeth Shove, and she always talks, she's done these great studies on bathing. So turn of the century, on average, you would bathe once a week, and your family would heat up the water and you would all use the same water. You'd have 1 or 2 changes of clothes. And so this practice of how we use energy has really fundamentally changed. And so this idea that you are using energy so differently today, most people bathe more than once a week, although I have some teenagers who maybe don't. But in theory, the average practice in America is to bathe a lot more. We use a lot more water. We expect hot water to be on tap. So we have hot water heaters and devices that are normal for us. And so when we're thinking about energy and when we're thinking about energy in our lives, one of the things I always like to point out at the beginning of this class is that depending where you are in the world, some people really today live like the US did 50 years ago. And some people in the world live like the United States lived 100 years ago. And so while we're thinking about, energy in our lives, each box is kind of a billion people here. You have 2 billion people on the planet that use energy like we do in the US. Those are the 2 blue boxes. You have another billion people on the planet who don't have access to modern electricity. And while this number has remained about 1 billion people, the percentage globally has gone down as we provided more electrification. So a larger percentage of people on Earth today have access to electricity, but the number remains about 1 billion. And then you have about 4 billion people on the planet who don't have enough, who would like to have more energy. My friend Suraj Dopla, his uncle in India, had to close his factory on Tuesdays because he didn't have enough power to run it during that time. So there's lots of places where they would like more electrification, more modern use of energy. And so thinking about, who has too much energy, that's probably us, me with my electric toothbrush, and guys that come and mow the lawn and have the leaf blowers there every few weeks at the condo, flying regularly. and then the people that don't have anything. And so these very different energy realities, I think, are something to keep in mind. If we all use the same amount of energy around the world, we would all have about as much as they used in Switzerland in 1960. So global energy use, were it equally distributed, would be as much per capita as Switzerland used in 1960. But this global map is actually one that really varies. And I like this global access to electricity map because it really highlights one of the most important and challenging pieces of energy in the future, of energy transitions in the future. And that's providing enough energy for people around the world. I used to be a Peace Corps volunteer in Burundi. I also like this map because Burundi is right in the center in Central Africa. And you can see that 9% of the people there have access to electricity. And so what your life is like when you don't have access to electricity, the 1 billion that don't have access to electricity, the 2 to 3 billion that don't have access to clean fuels, is just something that is part of the global energy story that is important to recognize as we go forward as well. Now, I want to shift gears a little bit from talking about energy access and how we use energy to think about our current energy systems, and in particular, the real risks that are facing these systems. The last couple of weeks, we've had lots of news stories about the fires. I'm originally from California, and so the dramatic pictures coming from the West Coast, California, Oregon, Washington burning, but also the storms hitting the Gulf Coast really highlight that the changing climate is not something our current energy infrastructure was planned for, is operated for, or is prepared for going into the future. And so this idea of us moving into a world with rapidly changing risks, and I'm thinking here mostly of climate risks, but we can also think about the social risks, the geopolitical risks, the cybersecurity risks that are facing our future energy system, make this story of energy transition all that much more urgent. It's not just creating energy systems that don't release any more pollutants or carbon dioxide. It's also creating energy systems that are able to withstand a changing climate, a changing global set of winds, fires, droughts, and water regimes. I was a professor at University of Minnesota for 16 years before moving here to Dartmouth 3 years ago. And the Upper Mississippi watershed is fundamentally different than it was a few decades ago. You have cities like Davenport, Iowa, that had 220 days at flood stage in 2019. And so you're seeing fundamental shifts in how water, wind, heat, dry are affecting our landscapes. This means that in the fire-generated ecosystems, the fire frequency is such that the trees that used to take 8 years to germinate a pine cone are now not able to reach that pine cone maturity. So you're having huge changes in what your ecosystem composition is, which again has implications on water, land use, and others. And so when you're thinking about energy systems, they're embedded in specific geographic contexts. And this idea of interconnected risks is something that is really useful to spend some time thinking about as we're thinking about how we're going to be creating our energy systems of the future. This map here, put together by the UNFCCC in 2018, talked about the interconnected risks from climate change. I think we can all see those pretty well this year, but the profound social instability at the heart of this map really highlights, I think, also the importance of energy in a world that is changing much more rapidly than even the more aggressive climate models were predicting. So the real question that I have is, given the needs for energy access, given this incredibly rapidly changing climate world where we need to both mitigate and adapt our energy systems, how do we create these systems that are addressing climate and weather risks, the cybersecurity threats, as well as the sustainability needs, while the promise and premise of the energy system ensuring reliable, affordable, accessible energy for the 7+ billion people on the planet. That's the challenge. And so as we're going forward, as we're working on these topics together over the next couple of weeks, I just want you to keep that global context in mind. I know it's really easy to think about our own lives, our own households, our own families, but I want to just plant our energy story in the story of the planet, in the story of the coming risks, in the story of human needs, in the story of environmental vulnerabilities as we move forward over these next decades. And frankly, I mean, the good news and the bad news is we don't have a choice. I mean, the energy system has to change if it's going to be working in the future. So I want to change gears just a little bit right now and talk about how the energy system today works in the world. And every year, the BP puts out the statistical review of world energy. This is the 2020 edition from, and what they highlight here, on the left side, you see world consumption. On the right side, you see the percentage of shares of global primary energy use. Green oil, red natural gas, and gray coal. And the important thing here that you should take away from this chart is when we're talking about carbon-free energy, we're talking about this. Depending on where you are in the world, but you're looking at 20% of global energy supply today is carbon-free energy. The rest of the energy we use on the planet collectively is from coal, oil, and natural gas. So I really appreciate people wanting to push renewables as fast as we can, but I think it's also very, very important to recognize how we get our energy today, and that as part of the story going forward. And why this is important not only for the solutions within the United States. I don't know how many of you heard today, there was just an article published in the Financial Times. China's committed to carbon neutrality by 2060, I think it is. So that's the big environmental story of the day. But how energy is used globally, here's the regional consumption patterns of energy around the world. North America on the far right, Asia Pacific, I'm sorry, on the far left, Asia Pacific on the far left. And I just want to highlight here the different consumption percentages of different types of fuel. Because it's really easy to sit in North America and think, okay, we have this much coal, we have this much natural gas, coal's gone down, look at this, we have all this renewables, hydro, and nuclear, those are our carbon-free sources, but that's not the story around the world. And so when you're thinking about global conversations or conversations about carbon taxes, you see that this energy story really depends on where you sit. Where you sit is so often where you stand. And so having some sort of perspective on where energy is different and why it's different around the world really highlights a lot of those geopolitics that drive our energy infrastructures, investments, and future deployment patterns of technologies. And so this story as well here of energy per capita by region is also an important one. When I lived in China, we often talked about, how much energy was used per capita. In the US, we like to talk about total emissions. Here, you can appreciate that in North America, we use about 2 times the amount of energy for our lives as we do in other parts of the world. And I just want to point out that red line on the bottom is Africa, where there isn't that much energy used per capita at all. And so thinking about these equity issues as we think about future energy use is also something that is embedded in the conversations. So we're coming into our quiz time now, because I see a few of you starting to yawn. And I will say we had the tea earlier, but it is also my bedtime. This is a map, 2019 installed wind power capacity in North America. So the total installed wind capacity is roughly 100 gigawatts of wind. 90, at that time it was 97. You can see where it is in the country. The real growth in Texas, in the middle of the country. So here is your quiz question. Every year, the US Department of Energy publishes the annual energy outlook. that projects what the energy mix will look like for the next 20 years. So in 1990, the Annual Energy Outlook projected the energy mix from 2000 to 2020. Now, you can vote on progress, how many, what you think it is, A, B, or C. How many megawatts of wind the Annual Energy Outlook projected we would have in 2020. So the correct answer was A, 800 megawatts of wind. We, the experts, were wrong by roughly 2 orders of magnitude. So sometimes when I'm having a really hard day about thinking about energy systems and energy system transitions, I go back to these numbers because we were wrong, and badly wrong. And we were wrong for many reasons. The numbers here were based on what we projected the costs of the turbines would be. We didn't take into account the global manufacturing and drives from other countries, nor did we take into account the huge investment in new transmission builds, whether it was from Texas to the Midwest to other parts of the US, that allowed for this wind to get connected to the grid. Nor did we take into account all of the shifts in control systems that allowed for wind turbines, wind plants now, not just a turbine, but a set of turbines operating as a plant to bid into regional electricity markets and be automatically controlled up and down by the grid operator. And so when you think about the story of wind, you really do need to think about this technological evolution of an energy system as it's responded not only to a wind turbine, but wind power on the system that's changed electricity markets, that's shifted technologies, that's changed siting rules and planning operations, not only in the United States, but around the world. So now we're going to put you into your final breakout group, where we're going to give you some opportunities to talk to your fellow colleagues about what you learned and where you want to go, and bring you back in 7 minutes for the wrap up. So we'll see you very soon. Thank you, everybody. We hope that you've enjoyed meeting some other people. I was just able to check out the chat when you guys were all gone. There were some great conversations happening there. I realized I have no ability to talk and do the chat at the same time. So I'm so happy we have so many smart, great people in this group to really kind of keep that conversation going. So please continue doing that. It's a really useful way to kind of engage in different ways. This is a chart here that I wanted to just kind of, I'm going to end with 3 more slides and then we'll kind of wrap up a little bit, but I hope you've had some good conversations and the high points, and feel free to write the different points in the chat. Also, we'd love your ideas. Is 3 people too many, not enough? Are the 7 minutes long, not long enough? Just give us a little bit of feedback so we can steer for future sessions. But this is a levelized cost of energy analysis. There's some controversy about how useful these charts are, but the most important thing that I wanted to show you was in the last decades, the steep declines in cost and prices of renewable technologies like utility scale solar and wind. And so you've had a real shift, driving that story going forward. And so that's important for us as we think about how energy future investments happen, and we think about this world going as well. But again, how this differs around the world, CIS, you're right, those are the former Russian states. There were some comments about that. North America, Europe, the leaders there, and in some parts of the world, it's really not happening very much at all. And so again, where you sit is so often where you stand when we're thinking about different energy areas. And the other piece that I think is important as we close is the story of electrification being the route to decarbonization, again, really depends on where you are. And so if you're in Asia Pacific, which today gets most of its electricity from coal, electrification might not be an environmentally beneficial answer. If China follows through on those very, very aggressive plans for decarbonization, you may end up with a very different story. I just want to put this little twist on our conversation because where you ask the question really helps to drive the answer that you have. And to contextualize our energy and our energy system is very, very important for us as we move forward on this. These slides will all be available for you as well. The same is true in the US, where we have some parts of the country that are much more carbon intensive in our electricity than other parts of the country. I always joke that if California and the Northeast really cared about climate change, they'd be doing energy efficiency programs in North Dakota, because the electricity there is 4 times as carbon intensive as what we have here. And so if it was climate that we were after, we'd be changing out light bulbs in Fargo. But no one has yet taken me up on that possibility. And then, you know, what percentage of global electricity is generated by different fuels around the world? Coal is still the dominant leader globally. And so some story of what is happening where. Energy is local, but it's also quite global. And then some of the geopolitical stories, you can also kind of pick apart energy here, where you're looking at both oil consumption, but also oil production. And you will all see how those geopolitics have affected our lives, affected our military engagements, and really made our energy stories ones that implicate us in many more ways than one might first imagine. Super charts here on major oil trade movements to highlight again who produces, who uses, and where it comes from. But the important thing here is these commodities are fungible, globally traded commodities and the largest markets in the world. And even with the crash of oil and the destabilization, and now the conversations of peak oil demand, we're still in some very interesting spaces to go. Gas is now being traded internationally, but we'll skip that for a later lecture. And I just wanted to end again with this idea of primary energy world consumption with the current share that is carbon free. Just so you know, if we're serious about decarbonizing the planet, what we're actually talking about, just to ground us in the story. It's going to take a few more than just some solar panels on some Vermont rooftops, I guess is the take home. With that, I'm going to turn it over to Kate. I want to thank everybody for staying up, in my case, so late. And I look forward to seeing you all over the next sessions, and really, again, give us feedback, what works well for you, other things you'd like to see, and take it away, Kate. Thank you, everybody.
So much, and thank you so much for your presentation tonight. I appreciate that for some people the night might be over, and for some it might just be getting started. So thank you so much for being here, whatever your circumstances. Next week, we have the pleasure of bringing our friends Amanda Graham and Stephen Doig to talk about the roles that energy plays in our lives today. So whereas the picture in this session was really big, we're going to zoom way in the next session and think about as a user of energy, what that system looks like for you and how you engage with whatever energy system is in your life. So we'll be back here, same bat time, same bat channel, if you get that reference, which I think, you know, ages me a little bit. And we'll see you here at 7 o'clock next week. We will be posting this recording, hopefully within a week of tonight. And we will also have the PowerPoint posted for you to reference. So hopefully we'll see you next week, and thank you all so much for joining.